I have started with an definition, with the definition of set. What is set actually? And then I am giving some examples also. So a collection is said to be a set when it is when or if it is well defined. Very important point, well defined. This is the most important point. A collection is said to be a set if it is well defined. Okay, first point, well defined. Second point, all the elements are different from each other. All the elements are different. Okay, and number 3, independent of order of occurrence. Okay, so a collection is said to be a set. Very important point. First point, if it is well defined. I am giving example about this one, well defined. And the second point, all the elements are different. All the elements has to be different, no two are same. Okay, and the last point, independent of order. That means it may be 1 to 3, it may be 3 to 1, all are same. Okay, so now I am giving an example about the well definedness. Suppose I am taking a collection of top 10 Bollywood superstar. Okay, suppose I am taking a collection of top 10 Bollywood superstar. Now, is it a set or not? What will be your answer? I think it is not a set. Okay, why? Because it is not a well defined. Top 10 Bollywood superstar, it is not a well defined. Top 10 superstar, it will be varied from man to man. Another one person will be listed top 10 Bollywood superstar, another person will be listed top 10 superstar. They will be varied, they are not matched. So it is not a well defined thing. So this is very important point. To make a collection to be a set, it is must be well defined. And the following points I am saying, all the elements are different and independent of order of occurrence. Okay, this is actually called set. Now in capital letters A, B, C, we are denoted the set. Whenever we denote a set by a capital letter, every time by a capital letter it is denoted. Okay. Now if a element, suppose a element A belongs to A, okay, a element, this is an element A belongs to the set A, capital A. So how we write? A, this is the sign, belongs to. Okay, if it is not belongs to A, if A not belongs to A, then we write in this way. Okay, this is belongs to A belongs to A, this is the sign, and A not belongs to A, this is A not belongs to A, this is the sign. Got it? Now how we represent set? Set are mainly represented in two ways. Number 1, roster form, and number 2, set builder form. Roster form and set builder form, in two ways set can be represented. Okay, now what is the roster form? Here in roster form, all the elements, go to your NCERT books, all the elements of a set are listed. The elements are being separated by commas and are enclosed within the brackets. Okay, all the elements of a set are listed and the elements are being separated by commas, and that means in this way. Suppose this one equals to 2, 4, 6. Got it? In this way we may write in the roster form. But in case of set builder form, you have to all the elements of a set possesses a single common property which is not possessed by any element outside the set. Okay, this is actually set builder form. That means how we write this one? This one we write in set builder form 2n such that n belongs to natural number and one less equal to n less equal to 3. So n will take the value 1, 2, 3 and then it gives 2 into 1 means 2, 2 into 2 means 4, 2 into 3 means 6. Okay, this is set builder form. I am repeating again, all the elements of a set possesses a single common property. That means I am written here in a property, in the property way. This is set builder form. In roster form means you have to write all the element explicitly. Okay, within a bracket and separated by the commas. Okay, now there are some standard set in NCERT book. You can see there are some standard set. Suppose this one, set up all natural numbers. That means taking the value from 1, 1, 2, 3, dot, 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 dot. Okay. Then this Z, set up all integers. Then this one, set up all rational numbers. Set up all real numbers. Set up all positive integers. Set up all positive rational numbers. These are some standard sets. Okay, some standard sets. Set up all positive real numbers. Now move on to exercise number 1.1. Okay, which of the following are set? Go through the problems, go through the question, justify your answer. First one, the collection of all months of a year beginning with the letter J. The collection of all months of a year beginning with the letter J. Okay, so you can list it here. What is the month beginning with the letter J? That means January. That means set is January, not February, March, April, May, June, then July, August, September, October, November, December, not will be included in the set. Okay, so there are only 3 elements. This is well defined. I am writing in roster form, so it is a set. Okay, so the well definedness is the important one. I am giving an example sometimes later. The second one, the collection of 10 most talented writers of India. This is not well defined. 10 most talented. This is not a well defined term actually. 10 most talented can be varied from one man to one man whenever they listed 10 men, 10 most talented writers. So it is not a set. The first one is a set. This is set. Second one, not set, not a set. Third one, a team of 11 best cricketer. Again, 11 best cricketer. So 11 best, this is not a well-defined term, okay, of the world. So not set. This is not a set. Okay, not a set. Number 4, a collection of all boys in your class. Collection of all boys. So in your class, you can identify the boys in your class, okay, and then you can list it in a set, write in a set form. So it is a set. It must be a set. The collection of all natural numbers less than 100. You can write within a second bracket. You can list it and then write it. This is well defined. So a collection of natural numbers less than 100. It is a set. Again, it is a set. Number 6, a collection of novels written by the writer Munshi Premchand. Okay, so we can listed the novels of Munshi Premchand. So it is a set, well defined. Number 7, the collection of all even integers. Again, it is a well defined term, even integers. You can write it. Okay. Number 8, the collection of questions in this chapter. In this chapter, we can list all the questions. So it is a set. Again, it is a set. And the last one, number 9, the collection of most dangerous animal of the world. Most dangerous term I am saying from the beginning. Most dangerous. It is not a well defined term. So not a set. Got it? Now go to question number 2. Here A is given as 1, 2, 3, 4, 5, 6. The first one, you have to insert appropriate symbol in that given box, okay, in this given blank. 5 blank A, and you have to fill it by belongs to or does not belongs to. Okay, so you can see that 1, 2, 3, 4, 5, 6. So 5 belongs to A. Number 2, 8. You can see the set contains 1, 2, 3, 4, 5, 6. It doesn't contain 8. So we use that symbol. Does not belongs to. Number 3, 0. Again 0 doesn't seem here in that A, given A. So 0 does not belongs to A. Number 4. The number is 4. Digit is 4. Is it belongs to or not? You can see that it belongs to A, so belongs to sign. Number 5, 2. Belongs to or not? You can see it belongs to A. Then 10. Belongs to or not? Doesn't belongs to. 10 is not in this set. Okay. Go to question number 3. Write the following sets in roster form. Okay, this is given in set builder form. You have to write it in roster form. Here A is given as x such that x is an integer. And minus 3 less than x less than 7. So this is given in set builder form. Whenever you transform it into roster form, then you have to write the elements explicitly. So what are the elements? The integers greater than minus 3 and minus 2, -1 0 1 2 3 4 5 up to 6 7 less than 7, so it does not contain the element 7. Okay, so -2 -1 0 1 2 3 4 5 6, this is in roster form. Number 2, B, x such that x is a natural number less than 6. X is a natural number less than 6. You know that natural number started from 1. So 1, 2, 3, 4, 5, excluding 6, because natural number less than 6. Okay, so 1, 2, 3, 4, 5. Number 3. The set is C contains those x such that x is a 2-digit natural number, 2-digit natural number such that sum of its digits is 8. So what are the numbers? X is a 2-digit natural number such that sum of its digits is 8. So we started from 2-digit, so 1 7, then 7 1. Okay, we can see 1 7 means 1 plus 7 is 8, 7 1 means 7 plus 1 is 8, then with 2 2 6 6 2. Okay, 2 6 because 2 plus 6 equals to 8, 6 plus 2 equals to 8, then with 3 3 5 3 5, 3 plus 5 equals to 8, and 5 3, that means 35 and 53. Okay, then 4 4 4 4 4 plus 4 equals to 8, then again with 5 we got 5 3. Okay, again starting with 6 we got 62, again starting with 7 it will be 71, nothing with 8 and 9. Okay, so the numbers are 17 71 26 62 35 53 44. These are in roster form. Okay, number 4. Number 4, D. D is given as x is x containing x such that x is a prime number which is divisor of (60). X is a prime number which is divisor of 60. This is in set builder form. Okay, now I am converting it into roster form. Prime number which is divisor, that means the prime divisor of 60. Okay, so started with 2. If we divide with the factorization 60, we get after factorization of 60 we get, after dividing 60 by 2 we get 30, dividing by 30 by 2 we get 15, dividing 15 by 3 we get 3 and 5. So the prime divisor will be 2 3 and 5. No two are repeated. I am saying at the beginning when I was saying the definition. Okay, all the elements belongs to set will be different from each other and also irrespective of order. Okay. Number 5, E equals to the set of all letters in the word trigonometry. 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 So in roster form, the set of all letters. Okay, so first letter T is here repeated, so I am writing only one instead of two. Then R also here twice, I am writing here once only. Then I arises here once only. Then G arises here one only. Then O twice instead of twice, you can write only once. Then N, then M, only once. N also only once. E, and then Y. Okay, these are the elements. TRIGONMEY. These are the different elements. So I am written here in roster form. Got it? The last one, F. Question number 6. The set is again F. The set of all letters in the word better. The set of all letters in the word better. So B only once, I have written here once. E here twice, I am written here once. T here twice, I am written here once. And then R. B, comma E, comma T, comma R. This is in roster form. Now move on to question number 4. Write the following sets in set builder form. Okay. Now we will move the roster form into set builder form. One of 4. Write the following sets in set builder form. Suppose A equal to 3, 6, 9, 12. That means in set builder form it contains the type of 3n such that n belongs to natural numbers and 1 less equal to n less equal to 4. So 3 into 1 means 3, 3 into 2 means 6, 3 into 3 means 9, 3 into 4 means 12. Okay, so this is in set builder form. Next one. Two, 4, 8, 16, 13, 32. Suppose this is B. Okay, this is roster form. Now in set builder form, this will be 2 to the power n such that n belongs to natural numbers and 1 less equal to n less equal to 5. Now see, 2 to the power 1 equals to 2, 2 to the power 2 equals to 4, 2 to the power 3 equals to 8, 2 to the power 4 equals to 16, 2 to the power 5 equals to 32. Okay, this is in set builder form. Now question number 3. Five, 25, 125, 625. Suppose see this one. Again we can write it in the form 5 to the power n such that n belongs to natural numbers and 1 less equals to n less equals to 2, 3, 4. Okay, 5 to the power 1 equals to 5, 5 to the power 2 equals to 25, 5 to the power 3 equals to 1 to 5, 5 to the power 4 equals to 6 to 5. Got it? Now question number 4 of 4. D equal to suppose 2, 4, 6 dot dot dot. So that means the set of all, this is set of all even integers. So it contains x such that x is an even integer. You can see 2, 4, 6 all are the even integers. Or you may say the multiple of 2n, multiple of 2, that means 2n such that n belongs to natural numbers. You may write also in this form 2 into 1, 2, 2 into 2, 2, 4, 2 into 3, 6 dot 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 dot. So the even integers. And the last one, the number 4 sorry, number 5. Question number 5. E, suppose E equals to 1, 4, 9 dot 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 100. So we may write it in set builder form in this way. It contains those n square such that n belongs to natural number and 1 less equals to n less equals to 10. So 1 square 1, 2 square 4, 3 square 9 dot 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 10 square equals to 100. Okay, this is also in set builder form. So up to question number 4 we have solved. Try to do question number 5 and 6 yourself in home. Okay, try it. Now the next discussion is the empty set. The empty set. Empty set. I'm starting with an example. Okay. Suppose is a set X such that X is a student presently studying in both classes 11 and 12. So is it possible? Is it practically possible? X such that X is a student presently studying in both classes 11 and 12. This is not possible. So the set contains no element actually. It is called a empty set and written as phi in this way. Okay, written in the form of phi. This set contains no element because a student presently studying in both class 11 and class 12, this is not possible. Okay, so this is empty set. So what is the definition? Now just move on to the definition. A set which does not contain, definition, a set which does not contain which does not contain any element is called an empty set or null set. A set which does not contain any element is called empty set or null set. Okay. Now one more definition. Finite and infinite set. You know that is very easy. A set which is empty or consists of a definite number of elements is called finite. A set which is empty or consists of a definite number of elements is called finite, otherwise it will be infinite. Okay. A set which is empty or consists of a definite number of elements is called finite, otherwise it will be infinite. Okay. We will solve some problem related to finite and infinite later. One more definition, equal set. About equal set. Two sets A and B are said to be equal. Two sets A and B are said to be equal if they have exactly same elements and we write A equals to B. Okay, two sets A and B are equal. Two sets A and B are equal, said to be equal if they have exactly same elements, and we write A equal to B. Okay, suppose that example A equals to 1 2 3 4 and B equals to 3 1 2 4. We have said earlier the order of occurrence doesn't matter, so here 1 2 3 4, here also 1 2 3 4, so here we can conclude A equals to B. These are the definition and examples of equal set. Okay, now move on to exercise number 1.2. Which of the following are examples of null set? The first problem. Which of the following are examples of null set? Just go through the problem. Set of odd natural numbers divisible by 2. Set of odd natural number divisible by 2. So you know that all the even numbers are divisible by 2 actually, but the no odd number is divisible by 2. So the set of odd natural number divisible by 2, yes, it is a null set. Number 1, null set. Okay, the number 1 is null set. Number 2, set of even prime numbers. Yes, there are even prime numbers. 2 is a even prime number, you know that, so we get one element, so it is not a null set. Not a null set. Null set means it contains no element. Number 3, x such that x is a natural number, x less than 5 and x greater than 7. It is not possible. X is a natural number less than 5 and greater than 7. Naturally, it is not possible, because simultaneously any number less than 7 or greater than less than 5 and greater than 7, it is not possible. A number less than 5 and greater than 7 simultaneously is not possible. So it is a null set. It contains no element. So it is a null set. Number 4, y. The set contains y. Y is a point common to any two parallel lines. Y is a point common to any two parallel lines. Any two parallel lines does not intersect each other. Okay, you know that any two parallel lines does not intersect each other. So there is no common point. So yes, it is a null set. Number 4. Yes, it is a null set. Now go to question number 2 regarding to finite and infinite. Okay, which of the following sets are finite or infinite? The first one, the set of month of a year. The set of month of a year, you can easily say that this is a finite set. You can list it in a finite way. So it is a finite set. Number 1. Number 2, the set 1 2 3 ... Actually this is the set of all natural numbers, so this is a infinite set. Okay, this is infinite. You can see that infinite set. Number 3, within the second bracket 1 2 3 ... 99 100. So its ends, that means containing finite number of elements, that means finite set. Number 4, the set of positive integers greater than 100. The set of positive integers greater than 100. So it is infinite. We can see it is infinite. It never ends. Therefore, it is infinite. Number 5, the set of prime numbers less than 99. The set of prime numbers less than 99. You can count it. It is finite. The set of prime numbers less than 99. So it is also finite. Okay. Now move on to question number 3. Question number 3. State whether each of the following set is finite or infinite. The set of lines which are parallel to x-axis. The set of lines which are parallel to x-axis. Set of lines parallel to, this is x-axis. Set of lines which are parallel to, it is infinite. Infinite lines can be drawn parallel to x-axis. Okay. So number 1, infinite. Number 2, a set of letters in English alphabet. The set of letters in English alphabet. You can list it and you can count it. Okay. So easily you can see it is finite. Number 3, the set of numbers which are multiple of 5. Multiple of 5. If you write it in roster form, you can see 5, 10, 15, 25. So it is infinite set. It's go on and go on, never ends. So it is infinite. Number 4, the set of animals living on the earth. We can count it. The set of animals living on the earth. The animals living on the earth, you can count it. So it is finite. Number 5, the set of circles passing through the origin 0 0. The set of circles passing through the origin 0 0. Set of circles. Set of circles passing through the origin 0 0. This is the origin. Set of circles. Infinite number of circles. We can draw infinite number of circles, so it is infinite also. Got it? Now move on to question number 4. Question number 4. In the following state whether A equal to B or not. That means this is related to equal sets. This is related to equal sets. In the following state, whether A is equal to B or not. Here A is given as containing small letter A, B, C, D, and B is given as containing the small letter D, C, B, A. So yes, you can see A, B, C, D in other order, in different order. Here also occurs A, B, C, D. So you may write A equal to B. Okay. Number 2. Here A equal to 4, 8, 12, 16, and B equal to 8, 4, 16, 18. Only one element matched. 4, 8, 16. 3 element matched. 4, 8, 16. But here is 12. Here is 18. Doesn't match. So A does not equals to B. Okay. Number 3. Here given as A equals to 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. And B is X such that X is a positive integer. And X less equal to 10. Okay. This is given in roster form. This is given in set builder form. Even integer less equal to 10. That means if you convert it in the roster form, you may write it 2, 4, 6, 8, 10. So they are equal. Number 4. Here A equal to X such that X is a multiple of 10. X is a multiple of 10. Okay. X is a multiple of 10. So X is a multiple of 10. So 10, 12, 20, 30, so on. But B is 10, 15, 20, 25. So many elements are there which doesn't match. Okay, so we may conclude here A not equal to B. Because this is 10, 20, 30, this is 10, 15, 25 does not belongs to A. So they are not matched. So therefore we may conclude here A not equal to B. Okay. Now question number 5 and 6, try to do it yourself in home. Okay. And next day we'll discuss about the subsets and the universal set, power set, and then Venn diagram, then the operation of sets. Okay. Thank you for today.